All right, so you should have control now, and you can take it away.
Okay, great. Yep, as we said, my name's Craig Evanego, and I'm going to sort of tag team with Mike here. We're going to present you some information about our spotter program and about severe weather as we head into the spring season here. Let's see. So there are some opportunities with the GoToWebinar for attendee engagement. You can ask a question. I think there's an option on the right-hand side of your screen to ask questions, and we'll try and answer those as we go on through the presentation. There's also the ability to raise your hand, so I think we'll see something pop up next to your name. I guess if you have a question or anything like that. Mike is running the presentation. He's actually in the office, which is why he has a mask on right now. I'm at home running the presentation or helping with the presentation from home. As Mike mentioned, there is going to be an email coming that should come to you tomorrow, and all of the handouts that are a part of this presentation, including a copy of the presentation, will be a part of that email. So as Mike said, you don't have to worry about quickly writing down links or anything like that you see in here, because you'll receive a copy of the presentation tomorrow. So everything you see here will be available to you with that. Let's see. So starting with a little bit about us, ways that you can find us. We have a new Instagram account. We also are available on Twitter, Facebook, YouTube, and of course our good old-fashioned web page there. And it covers all of the weather information that you'd like to see for central Pennsylvania. And we're going to start with one of our 5 poll questions here. This is interactive, so we'll see how this works. But we're curious how you heard about this training session. And I'm going to launch the poll here now and give you a chance to answer. Okay, we see your answers coming in now. We'll give it a few seconds. Okay, it looks like the answers have stopped here, so we'll go ahead. I'm going to try and share this with you. So here's the results. Looks like kind of an even break between email and word of mouth for the most popular way that you heard about this, but kind of a variety of ways. And yeah, I know we had information about it on our website, but however you heard about it, we're glad to have you here with us. We very much value the spotter program, and so we're looking forward to having you as a part of the team and to explaining what the program is all about. So a little bit about the National Weather Service. Our parent agency is NOAA, which is the National Oceanic and Atmospheric Administration, and we fall under the U.S. Department of Commerce, so we are a federal agency. The primary mission of the National Weather Service is protection of life and property, and we do that through the issuance of forecasts and warnings. Let's see here. Here's what the organization of the National Weather Service looks like. We have 9 national centers. You can see them there on the left. Probably the ones that you're most familiar with would be the National Hurricane Center, which is located in Miami, Florida. The Storm Prediction Center in Norman, Oklahoma. They issue all of the severe thunderstorm watches, tornado watches, things like that. And the Weather Prediction Center recently relocated. They were in Camp Springs, Maryland for a long time, but a couple of years ago they relocated to College Park, Maryland, which is not far from the University of Maryland campus. Now, our office, which is in State College, Pennsylvania, is the Central Pennsylvania Weather Forecast Office. There's actually 122 offices around the country. We're one of those 122 offices, and we cover all of Central Pennsylvania. There are actually 5 offices that forecast for portions of Pennsylvania. Our office is the only one that our county warning area is entirely contained within Pennsylvania, but I'll show you a map coming up here of the other offices that serve parts of Pennsylvania. There are also 13 river forecast centers with the National Weather Service. One of those is co-located with our office. It's the Middle Atlantic River Forecast Center, and they cover, in Pennsylvania, they cover the Susquehanna and Delaware river basins. The western part of the state is covered by the Ohio River Forecast Center. They're located in Wilmington, Ohio. They cover like the Allegheny Basin, the Monongahela Basin, the Ohio River Basin. So Pennsylvania is kind of split in two between the river forecast centers. There's also 6 regional offices. Our office falls in the eastern region of the National Weather Service. And National Weather Service headquarters is in Silver Spring, Maryland, just north of Washington, D.C. So this is a nice map showing where all 122 of those weather forecast offices are located. You can see us in the red circle. We're Central Pennsylvania, CTP. But there's a lot of offices, and they're generally located or co-located, or at least nearly located by radar sites around the country. Now here's a map showing the offices that cover Pennsylvania. And as I said earlier, there are 5 offices that cover portions of the state. Cleveland covers the northwestern few counties there. Binghamton is northeastern Pennsylvania. There's an office in Mount Holly, New Jersey that covers the Philadelphia area. And then, of course, southwestern Pennsylvania is covered by the Pittsburgh office. Those other 4 offices also cover portions of neighboring states. And our office is in State College right here in the middle of central Pennsylvania. And here is a little look inside of our office. This is the operations area. One of our forecasters working at our workstation, which is called AWIPS. You may have heard of it. This is where we produce all of our forecasts. This is where we monitor the radar when there's severe weather. This is basically where it all gets done. You can see that there's, let's see, 6 monitors here. This on the left is actually a dual-headed PC. And I believe, let's see, this is, I think this is a text workstation. And then these 3 are part of AWIPS, and we can look at text and graphical products in there. Our office is comprised of 14 forecasters doing the weather forecasts and warning operations. We have 6 electronic technicians. They're the folks who work on our radar. They work on our NOAA weather transmitters, our automated observing sites around the Commonwealth. They're the folks who keep all of that up and running for us. We have 1 service hydrologist who serves basically as a kind of, he interacts between us and the river forecast centers. Our science and operations officer is basically the training expert. He's the person who makes sure that the staff is up on the latest training and the latest, I guess, technology and meteorology. We have an observations programming leader, the OPL. That person is in charge of our cooperative observer network around central Pennsylvania, and that's a little bit different from the spotter network. The cooperative observers actually monitor climate data for us. So they give us daily climate reports, high and low temperatures, precipitation, snowfall, snow depth, things like that. And they really, there's a nationwide network, and they comprise basically the climate data for the United States. And we have our OPAL manages that program. We have a warning coordination meteorologist. They are basically the outreach person for the office. They kind of manage all of the office's outreach efforts. We have an administrative assistant and then an MIC, a meteorologist in charge. And we are open 24/7. The weather functions 24 hours a day, 7 days a week, 365 days a year, and so do we. So we're there around the clock. And here's what a typical shift looks like in our office. We have on the day shift and the evening shift, we have 3 folks in the office. We have a short-term forecaster, a long-term forecaster, and a person who mans the public service desk, which is basically monitoring products as they go out and answering phones, talking to the media, things like that. And this would be, as I said, We have these 3 people on the day and evening shift. The night shift, we don't have a public service desk person. We just have 2 folks in on the night shift, the short-term and the long-term forecasters. And when the weather gets busier, of course, we end up having to bring in extra people to monitor radar, things like that. So this would be in an instance where we have maybe a big winter storm or a severe weather event. In addition to the short-term, long-term forecasters and the public service desk, we also bring in extra people to watch the radar. We have a decision support meteorologist who basically is monitoring the weather if we have any sort of events going on in our county warning area, especially in the summertime. That can get busy with fairs and festivals and things like that. This person is basically monitoring the weather for those folks to make sure that there's no heavy weather headed towards any of those outdoor events where there may be vulnerable populations. We also might have a social media person who's putting the latest radar, the latest information on warnings and things like that out onto social media. And for the biggest events, we'll have a storm coordinator who kind of coordinates between everybody, just make sure that we're all on the same page, that we're not issuing warnings on top of each other or anything like that. That person is basically just making sure that we're all focused on what we need to be doing. Some key pieces of equipment that we use. Doppler radar is big, especially for severe weather operations. The radar for central Pennsylvania is located about 15 miles west of State College. It's up on the Allegheny front on a part of the ridge that's known locally as Rattlesnake Ridge, and that is off of Rattlesnake Pike, which is between Unionville and Phillipsburg in Center County. But it's way up, it's at a pretty high elevation, so it has a good view of all of central Pennsylvania. We also utilize satellites, satellite data for making our forecasts and our warning operations. I think this is a picture from our computer room, so of course computers are very important for us. And this is a picture of an automated surface observing site, and we have those at all of our all of our airports around central Pennsylvania. I know we have one at University Park, which is here, the airport in State College. Middletown is the official observing site for Harrisburg at the airport in Middletown. We have one at Williamsport, which is also an official climate site in central Pennsylvania. Bradford, Johnstown, Altoona, all of those airports have these automated observing sites. So now I'm going to get into a bit of the SKYWARN program background here. The SKYWARN program, a group of trained volunteers who give us a hand whenever there's any sort of hazardous weather. The important part is that as a part of our spotter network, you are ground truth for us. You're our eyes and ears out in the field. You're seeing what's happening. We're up here in State College. We are looking at our radar and we're trying our best to figure out what's happening all over central Pennsylvania. But our spotter network is the people who are actually out there with their eyes on what's happening, and you can help us verify what we're seeing and to better understand what's actually happening on the ground. And as I mentioned earlier, it's a very important program, and we very much value our spotter network. Very important to us, helping us to understand what's happening out there. One of the bullets here adds credibility to Weather Service products. That's there. You'll often see when we issue severe thunderstorm warnings that it'll say radar indicated severe thunderstorm. As I said, we're looking at radar, but we don't know exactly what's happening on the ground. But if we get a spotter report, a spotter, say in Clearfield County, may call in and say, hey, I have golf ball size hail in Clearfield right now. We can add that to our warning product so that folks downstream from that warning understand that it's not just radar indicated. There's actually been an observation that this is producing golf ball sized hail, and that adds credibility to the warning. I think when people hear that, they're more likely to say, oh wow, this storm's doing something, we better take shelter. The SKYWARN program, it's a big program. Just for our office in central Pennsylvania alone, we have over 3,000 trained spotters. You expand that to statewide and we're getting to 10,000 spotters. Nationally, nearly 300,000 people are part of the spotter network. So it's a big program, very important to the National Weather Service, and we're proud to have such a big network. And one thing we wanted to mention is you're receiving your training through our office today, but that training is portable. So if you move outside of central Pennsylvania, if you move somewhere else in the country, you can contact your new local weather forecast office and let them know that you've been spotter trained, and we can transfer your credentials over to that office and you can become a spotter for them. Even if you don't move, I know sometimes we'll get calls from trained spotters. I know we've had them in the past. Say a spotter from the Washington, D.C. area might be in Gettysburg for the day, visiting the battlefield or something, and they'll give us a call and they'll say, hey, I'm a spotter. I was trained by the Sterling office, the Washington, D.C. office, but I'm in your area and I wanted to let you know that, we're seeing, strong winds here and there's some wind damage. So we can get reports from spotters from other offices. And if you're traveling around the country, if you have the number for an office, don't hesitate to call and let that office know that you're a trained spotter and you might be observing some sort of severe weather. They'd be happy to hear from you. Today's class, we're going to cover some of the basic aspects of observing weather, give you an idea of what kind of reports we like to hear and how those reports can be the most accurate. We'll go over some key weather definitions and look at some different weather elements with a focus on severe weather since we're heading into the warm season. And when this course is complete, you'll be a certified member of the SKYWARN team. You'll be one of our official SKYWARN spotters. We had mentioned that you'll be getting an email tomorrow. I believe that there will be a certificate attached to that email. That'll be a certificate saying that you're one of our trained spotters. I've got another poll here for you. This one is, we're wondering when the last time was that you took a SKYWARN training course. Maybe it's your first time, but I'm gonna run this poll here, and we'd like to know. So here we go. See the answers trickling in. Looks like a lot of first timers. That's good to see. Okay, I'll share those results. So you can see the majority of people, it's their first time, or for some folks, this is a review, but the last time they had it was just in the last couple of years. For folks who are existing spotters who are just getting a refresher training here, welcome back. We're glad to have you. And for first timers, thanks for your interest in our program. We hope you get a lot out of this training. Let's see. Sorry, it's a little bit sluggish here. There we go. We wanted to bring to your attention a new briefing page that we have that's linked through our main website. Our main website is weather.gov/CTP Charlie Tango Papa. And this briefing page, if you just add the word briefing to the end of that address, it'll take you to a page that looks like this. And you can see there's some tabs at the top. Current weather, thunderstorms, winter weather, any sort of weather that you're interested in. If you click on those tabs, you'll find a variety of products related to that. And there's a lot of weather information out there through our website, and we made this site to try and bring all of it together so that you had a kind of a one-stop shop where any kind of weather that you're interested in or looking for, you can find it through this site. We also, I don't know how many of you are familiar with our briefings. We do briefings usually if there's any sort of significant weather happening in our area, a significant winter storm, or we're expecting a significant severe weather outbreak. We usually will issue briefings for those a couple times a day. And at the top of this briefing page, you have a link to our latest weather briefing. Probably right now, there's nothing active in there. I know we had something for last night's snow, but I think that probably has been taken off the web page as that's history now. Let's see. I have another useful website for you. There we go. Now this is weather.gov and forecast points. And as Mike said earlier, you don't have to worry about writing all of these addresses down because you'll be getting a copy of this presentation in an email tomorrow. So this will all be at your fingertips when you get that. But the nice thing about this site is that you can type in a zip code wherever you live, and you can find all kinds of weather information in there, all kinds of variables. This shows daily weather for, it looks like the upcoming week, max min temperatures, winds, clouds, precipitation. You can also get hourly data for whichever days that you're interested in. And again, you can see temperatures, wind chills, winds, probability of thunder, things like that. And you can look at it graphically through this website as well. You can see a temperature graph there, sky cover, wind gusts. And this site is probably the best location for graphical display of the variety of weather variables that the Weather Service forecasts for. Let's see, now I'm going to cover just real quickly a bit about winter weather. There's just a couple slides here. As I mentioned earlier, this is mainly going to focus on severe weather, this spotter training, but we did want to touch on a little bit of winter weather here. And I know at least here in State College, we had some off and on snowflakes here today, so winter's not quite done with us, but I think we're headed in the warmer direction. But we're going to just touch on winter weather here real quickly. The first thing is measuring snow, and this is something we'll get a lot of questions about. And I know even internally, some of our forecasters and things sometimes will have a bit of a debate of what the proper way is to measure snow. So we've got 6 steps here that if you follow, you should be in good shape for measuring snow. The first, of course, is supplies, which is pretty basic. Of course, you'll want a ruler. You want a flat board, preferably painted white. If it's a dark color, you may end up melting some of that snow. So painted white is probably the best way to go. And you'll want a flag because once it starts snowing on top of your white board, you'll need that flag to let you know where your board is located. And speaking of location, the second step is planning for a good site for your board. You'll want it to be away from tall objects such as your home, trees, things like that may have an effect on the snowflakes falling, whether they get to your board. You'll also want it to be in a relatively sheltered area so that you're not getting drifts, either drifting snow onto or off of that board. In the third step, you can see the setup, which is pretty straightforward. Just finding that good location that you identified in step 2, putting your board out there and having a flag to let you know where it is once that snow falls on it. Measuring the snow, we like to get reports to the nearest 1/10 of an inch for snowfall. So using that ruler, you can get that. One of the questions we often get is, how often should I clear off my snowboard? And it's my understanding that you want to do that every 6 hours. And sometimes we'll get reports from people who are clearing their boards hourly, and those values tend to end up coming in a little bit inflated. Those numbers are a little higher than what we're seeing elsewhere. So I think that doing it every 6 hours, it allows for a little bit of compaction to happen, but that's the preferable way to do it. Now on this slide, I think it actually says once daily. This is an instruction for our cooperative observer network, but for our spotters and people who are calling it in as the storm is happening, clearing every 6 hours is the best way to give us those reports. When the snow stops, you want to take that final measurement as soon as you can after the snow stops to let us know your total. And of course, for reporting, social media has been big for us, especially Facebook. We got Facebook and Twitter. We get a lot of snowfall reports through that. So those are probably the top options. We will also give you a phone number. We have a spotter network phone number, so just our spotters can call into that. So that's going to be another option, and I think that'll be later on in the presentation. We will share that spotter line with you. Measuring ice. As you know, freezing rain can be as impactful as snow, if not more so. Freezing rain is when you get the precipitation falling as liquid the whole way to the ground, but once it gets to the ground, it freezes on contact. It might be on the ground, it might be on your car windshield or on tree branches, but it's coming down as liquid and then freezing after it lands. The best way to measure that, oftentimes on a tree branch or a shrub, is a good way to get an idea of how thick it is. And of course, with gravity, you'll typically end up with a bit more ice on the bottom than you will on the top. So we recommend taking measurements of both the thickness on the top and the bottom of that branch, and then dividing it by 2, so basically getting average. And that is your ice thickness. Another way you can get ice thickness is on flat surfaces, such as a deck rail or something. And of course, the way you measure it on a branch wouldn't apply. You could probably measure it straight forward on a deck rail. But if you do off of a branch, this is the best way to do that to get an accurate report. And next, I'm going to hand it off to Mike Colbert, and he's going to tell you a little bit about Weather Service products, watches, warnings, and advisories, and then he'll start to get into some of the severe weather information for you.
Thanks, Craig. And just before I start with that, I did see one question come in. The question was, it was early on in the presentation, if I already have a spotter number, how do I keep the same number? So actually this year we're going to kind of do away with spotter numbers. If you're registered as a spotter, you're still going to be a valid spotter that is portable, as Craig mentioned, and of course this will be some good reinforcing training. But we're actually doing away with spotter numbers. All that's really going to matter to us in our database is the name, your name, and your location, which we'll always ask the location from this point forward, because people do move around quite a bit. People can be in different locations when they call in reports. So that's not going to be quite as important anymore, at least for this office. But a really good question, and I ask that if anybody else has questions that they think of, they can just type in the question in the question box in GoToWebinar, and we will address them as we see them come in. All right, so I will proceed here with National Weather Service products, including watches, warnings, and advisories. So the Weather Service actually has like a 3-tiered approach to the products. So starting with ample time before the event, so this is usually in the days 1 to 2 or even longer away from happening, outlooks are going to be the first thing that's issued. So a lot of those will come from the Storm Prediction Center. The Weather Prediction Center also has outlooks for excessive rain, which will equate to a flash flood risk. So that's the first step, and that's also when the confidence in the forecast is lowest because of how distant it is in the future. Then once things become a little bit more confidence and the time to event is now closer, that's when watches are issued. They could be severe thunderstorm watches, tornado watches, flood watches, and flash flood watches. Those are typically issued on the day of, or maybe the day before in the case of some of those hydro flood watches. And that's when the conditions are starting to increase. We know the general area where the highest threat is for these weather hazards. And then the last thing is the warnings. And that's when the confidence is quite high, and we can pull the trigger on saying, hey, people in this area need to take action now. This is either ongoing or is pretty much almost guaranteed to happen somewhere within that warning polygon very shortly. So the differences between the outlook, watch, and warnings, I went over this a little bit in general terms, but a little bit more specific here. Outlook is when weather events are possible. So confidence levels, we're looking at a 30, like a greater than 30% chance, but less than 50% chance. And the lead time generally ranges for severe weather and for excessive rainfall, generally 3 to 7 days in advance. We'll start knowing about this. The Storm Prediction Center lets us know where the severe weather outlooks are going to be, and the Weather Prediction Center puts out excessive rainfall outlooks. And we put out our own hazardous weather outlook, which has that information as well as like a spotter activation that's included in our hazardous weather outlook. You can always check that. And this is really to give a heads up. We don't have details yet at that point. We won't know exactly where it's going to be or exactly whether or not there's going to be severe weather. But it's really just for situational awareness, and this is also the stage where we start talking about it in our forecast discussions and on social media and stuff like that too. Then the next phase is the watch, and this is when conditions become favorable. As far as probabilities, we're talking 50 to less than 80% chance of happening. For the severe thunderstorms and tornadoes, the lead time is going to be a few hours, and for river flooding and flash flooding, it might be as much as a day or two. Longer lead time if we know that there's going to be like a big heavy rainfall event moving up this way, like for example, the remnants of a tropical cyclone. We might have a flood watch up 2 days in advance if that's the case. So increased lead time with those. Some watches will result in bad weather and some will not. So if we have a watch up and nothing happens, some people might say, hey, they're crying wolf, nothing happened here, they were wrong. But because our trigger for a watch is a 50% confidence, that really does mean that we're kind of supposed to be wrong half the time. Well, not wrong per se, but 50% of the time something won't happen in part of that watch. Of course, if we knew that the chance was going to be higher, we would issue a warning, not a watch. And that's the last thing here. Warning is greater than 80% confidence, not necessarily 100%, but it's going to be pretty much the point where if you're in that warning, you want to take action, and lead times can range from a few minutes, especially in the case of tornadoes. I think the average lead time for tornadoes is about 15 minutes now, but that is lower in Pennsylvania because of the nature of our tornadoes. They spin up very quickly and they're not on the ground for very long. So the lead time for tornadoes can be just a few minutes. So really, if you got a tornado warning, you really want to take shelter immediately. Okay, so where to find the outlooks. This is an example here of the Storm Prediction Center's outlooks. You can find this on spc.noaa.gov. And the Storm Prediction Center's outlooks come in the form of both text product and graphical. This is actually the hazardous weather outlook on the left. So this is a text product that comes from our office. I mentioned that the hazardous weather outlook has the spotter information statement. This is an example here. Spotter activation is not expected at this time. But if things were like a higher chance of happening, maybe something's going to be, instead of isolated severe storms, maybe that would say that spotter activation is expected. But this is where we would put in our confidence level and what kind of severe weather we're expecting. And then this on the right here comes from the Storm Prediction Center as the outlook categories. And the way this works is anything that's light green is going to be general thunderstorms, where thunderstorms are going to be possible, if not likely, but they're not expected to produce severe weather. So not expected to produce a tornado, nor winds in excess of 58 miles an hour, nor hail in excess of an inch in diameter or greater. If those severe threats are possible, then the Storm Prediction Center will give it a higher outlook. So the second level, well, first level of severe is going to be marginal, and then the second level of severe is slight, and then third level here is enhanced, and then the only two higher than enhanced are moderate and high risk. And moderate and high are very rare around this area. You'll often see them at least a few times a year in the Great Plains and the classic Tornado Alley, and also especially in the past few years, and even this year twice already, there's been a high risk down here in the southeast United States, like kind of around Alabama or Mississippi or Georgia, where there is a kind of a secondary tornado hotspot in that part of the country. But yeah, here around this neck of the woods, usually we'll see a lot of slight risks in the summertime, and then maybe once in a while an enhanced risk, on average probably twice a year. And this is a little bit more detail about how those categories work. So like I said, thunderstorms, just general thunder is when no severe weather is expected. Marginal is going to be isolated severe storms that are possible. So not quite likely yet, but there might be here or there a severe thunderstorm, and it's probably not going to be extreme severe. It'll probably be lower end marginal where we just make the threshold to get the severe weather. Slight risk is when scattered severe storms are possible, so they're going to be just a little bit more widespread, and maybe some isolated intense storms possible at that point. So the higher end severe is possible but not likely. Enhanced, now you get numerous severe thunderstorms, and a few of those could be intense. So instead of isolated intense, we're now a few intense. And this example here on the left is actually from last year when a derecho came through. And we'll talk a little bit more about derechos in a bit, but came through with a pretty widespread swath of damaging wind. So that was a good example of enhanced risk. Moderate risk is going to be widespread severe storms, and several of those could be intense, maybe even some long-lived tornadoes. It's going to be moderate risk. And then high risk is really reserved for the most extreme cases at that point. And some schools are even considered closing, especially or an early dismissal to make sure that people aren't out on the roads while the severe weather is going to come through, because when you're talking about a high risk, there's often a decent chance of long track tornadoes, which you just don't want to mess with. And there's a picture of an example there on the bottom. So luckily, yeah, like I said, we don't get many moderate or high risk in this part of the country. This is an example here of what a watch looks like. So this is actually the derecho from that event where I showed you the outlook, what the enhanced risk looks like. You can see that the watch ended up taking almost that exact shape. So a very good forecast with lead time using that outlook. Now we're one step closer, higher confidence, a watch is issued. And you can see that usually when the watch is issued, either there's already ongoing convection or thunderstorms like you see here, or it's going to develop shortly. And we have a good idea of where exactly that's going to track, and we can kind of, in the case of a derecho at least, we can track that out in time and know with pretty good confidence what that watch should look like. But not all severe weather is so clean cut. Some of it's a lot more scattered or isolated. And then the watch box, you know, not everybody in that watch box will get hit by the storms. Of course, there'll be more areas that don't get the severe weather in those kind of cases. That's what a watch box might look like. And then the warning, this is an example from actually the same day, but later on in the afternoon. So another round of thunderstorms developing. But you can see as far as the scale goes, the size of a warning is, of course, much smaller than the size of a watch. And this is where people in this polygon should take immediate action to get inside. They don't want to be around outside while this storm's coming through with quarter-sized hail. And also, you don't want to be sitting outside or near a tree, under a tree, not only because of the lightning, but also because of the 60-mile-per-hour wind gusts that are noted with this severe thunderstorm warning. So you can see also, this is what the text of a warning looks like. You can see it always tells you how we detected the severe weather. So that's in this source statement. It says radar indicated. Like Craig said earlier, one of the reasons our spotters are so important and valuable to us is that if we get a report in real time that a storm just knocked down a tree in Center County, we're going to know, okay, we have verified that this is a severe thunderstorm, and we'll put that in the source. Instead of just saying radar indicated, it'll say a trained spotter reported a severe thunderstorm, knocking down trees in Center County. And then when somebody reads that text, it'll give them even more incentive to take action, be safe, and to get to shelter. So severe summertime weather. And of course, this maybe we should actually change this slide. This stuff doesn't only happen in the summer. This can happen any time of year, but things do, the majority of the severe weather happens in the summer, but can start as early as April is usually when the ramp up is, but it can occur rarely any time of the year, like including the winter time. December has had once in a while a couple severe thunderstorms too. But severe thunderstorms come with a variety of hazards. There's tornadoes, which are the classic rotating column of air with the very violent winds. If you ever see one of those, of course, you want to take shelter immediately in a sturdy structure, ideally below ground, like in a basement. But if not, then you want to be in an interior room on the lowest level of a home. That is usually safe enough for Pennsylvania. I guess a lot of our tornadoes are weaker, and a lot of the EF0s and EF1s and even EF2s are quite survivable if you don't have a basement, as long as you get into your interior room and you have a well put together home. Then, of course, severe thunderstorms also may have hail. Here's a picture of what looks to be about a baseball-sized hailstone. And the action item with hail is you want to move indoors and away from windows. Lightning is kind of self-explanatory. We all know what it looks like, and we know that even non-severe thunderstorms can have, do have lightning. Every thunderstorm has lightning. That's where it gets the sound of the thunder from. Wind, the action item is move indoors and away from windows and definitely away from trees. And then flooding can also occur with severe thunderstorms. So what actually makes a storm severe? The wind has to get to a certain threshold, and that's 50 knots, which is the threshold we use, but that equates to 58 miles per hour. So if a storm has wind gusts, so it doesn't have to be sustained, but a gust at least that strong, then that's going to be a severe thunderstorm. And then the threshold for hail, if you see a storm come through with penny-sized or nickel-sized hail, that's not quite severe yet, but if it has quarter-sized hail, the size of a quarter coin, which is 1 inch in diameter, that's going to be a severe hailstone, a severe thunderstorm producing that hail. And that's actually the 1 inch threshold is the maximum dimension. So if you have a hailstone that has spikes on it or is not quite a perfect sphere and maybe a little bit elongated in one direction, as long as that longest dimension is 1 inch or greater, then that's going to be a severe, that's going to meet severe criteria. And then any thunderstorm that has a tornado is also considered severe. Doesn't matter how strong the tornado is, as long as there is a tornado, that's considered severe. And then other threats, of course, we talked about this. All storms have, all thunderstorms produce lightning, and those that produce heavy rain, and especially those that are slow moving and producing heavy rain, have a flood threat with them as well. So what about the subsevere storms? What do we do at the Weather Service about them? Of course, we're going to monitor them closely. We're going to see if they're trending towards severe limits, and if they do, we might issue a warning. But if they are not trending severe, we will actually issue a special weather statement. This is something that not everybody knows about. They're a little bit less common for people to receive them, but you can access them on weather.gov, and there's some apps, private sector apps that you can go and download and access them there too. But if you can access them, if you can find them on the web or wherever else, they are useful because we do issue them when storms are going to come through and produce maybe nuisance type strong winds or hailstones that are in that penny to dime to nickel size range, but they just don't quite make it to the severe limits. So typically winds of, usually we want to issue a special weather statement for 30 miles per hour, but if it's between 50 and 55, then often we do issue those special weather statements. And P to nickel sized hail. And again, these do not set off any tonal alerts. They don't trigger the emergency alert system. And it's pretty rare that they trigger phone apps, but they are a product that we put out and we just wanted to make you aware of that. So next, I'm going to talk about thunderstorm ingredients. So what meteorologically actually has to come together to produce thunderstorms. And yeah, so there's 3 ingredients that are required to make a thunderstorm. The first is instability. Instability is what's required to get air to rise up, and you can see in this example here on the right, this photo, thunderstorms are by nature very tall. And they're tall because air is rapidly rising in the center of it. You can't tell by just looking at it, but air in the middle of this cloud is probably moving straight up at a speed of probably on the order of 50 miles per hour or greater. So instability is necessary for that to happen, and we'll talk a little bit about how instability happens and you know, what's necessary for that. Next ingredient is moisture. If you don't have moisture, then you can't get the clouds and you can't get all the thunderstorms to develop. So that's pretty self-explanatory. And then lift is something that triggers a parcel of air to start ascending upward. Instability is what keeps it going upward and forces it to accelerate and get faster and faster. But the lift is the mechanism that first gets it moving to begin with. And often that occurs with the passage of a cold front or a warm front or something that kind of nudges air near the surface to start moving vertically upwards. And one more ingredient, this is not necessary for every thunderstorm, but for severe storms, most of them also require wind shear. And we'll talk a little bit more about that on the next couple slides. But first, we're going to talk about instability. So I mentioned this is what's necessary for parcels to accelerate upward and obtain that really fast speed. So the way this typically happens, especially in the summertime and the warmer months, is the sun will heat the ground, and then the ground heats the air, and then this layer of air near the ground is actually quite a bit hotter than the air even just a few feet above it. So it's going to start to rise up, and then if there happens to be a colder air mass aloft, it's going to continue to rise up. That warm air rises because it's less dense, it's more buoyant than cold air. Cold air sinks, warm air rises. So if you get this air that's warmed by the ground, which is earlier warmed by the sun, you get that rising up through cold air, it rises even faster. So that's kind of the concept of instability. The hotter the ground and the colder the air aloft, the greater the instability is. Yep. So next, on to moisture. Moisture is needed for the clouds to form and for precipitation to occur. Moisture also increases instability. Another term for instability is CAPE, which is the convective available potential energy. We don't need to worry too much about the technical details there, but moisture does increase instability. And why is that? That's because when water vapor in a rising parcel of air condenses to form cloud droplets, the parcel is actually warmed further relative to its surroundings because of what's called latent heat. And this warming, like I said, as long as these parcels are rising up through cold air, the warmer they are, the faster they're going to rise. And if they're being further warmed by the condensation itself, they're going to get warmer and rise faster. So moisture is kind of linked with instability itself. It's a separate ingredient, but kind of correlated. And then next ingredient, the third one here, is lift. Lift is needed to create clouds and thunderstorms. Different examples of things that can force air to rise. I mentioned the cold front. And this is kind of a little schematic of the air circulation that typically occurs when a cold front comes through. So here's the cold front moving in from the left, and you can see that the cold air is kind of like a wedge near the surface of the atmosphere, the ground, so the lower parts of the atmosphere. And you can see that as that moves through into the warmer air is actually forced up and over it. And that gets those parcels moving up to begin with. And then if there's instability, if this ground is warm, which it probably is in this case, because you see it's a pretty sunny day out ahead of this storm. This ground is warmed by the sun. It's warmer than its surroundings, and potentially there might be some colder air up here. Once you get that lift going above that into that colder air with that instability, it'll form into a thunderstorm. And that's what's happening there. Another example of a lifting mechanism is a warm front. So a little bit different here. Here the warm front is actually moving again to the right, but the cold air is actually receding. So here the cold air is moving in for the cold front case, but for the warm front case, cold air is moving out to the right, and warm air is actually moving, kind of gliding up the back side. So this is typically more of like a gentle glide up, just because the slope of the cold air on the backside, on the warm front side, is just it's more of a gentle slope as opposed to this sharp slope in the cold front case. But nevertheless, it's not shown in this picture, but there can still be tall thunderstorms that can form here if there is instability. And then another case that actually is pretty relevant here in Pennsylvania for providing lift is what we call orographic effects, which is essentially the influence of terrain on the weather. So if you have air that's, let's say there's a wind blowing in from left to right, as the wind hits this mountain or hill or ridge or whatever it is, obviously the wind can't just go straight through the solid object, so it's going to be forced up and over it. And on the windward side, which is where the wind is coming from, as that air rises, that's going to be the lifting mechanism, and it will rise and go into cooler air. It's going to condense and form a cloud. And if the air happens to be unstable, you can get a tall thunderstorm on that side or towards the top. So those are a few good examples of what might provide lifting mechanisms. I mentioned that most severe thunderstorms also have wind shear, and wind shear can come in two forms. There's directional shear and there's speed shear. So directional shear is a change in wind direction with height. So as you go vertically upward in the atmosphere, if the wind is coming from different directions, even if the wind isn't changing speed necessarily, that's still a form of wind shear. And then the other form is speed shear. So even if the wind is all coming from the same direction, if there is a difference in the speed vertically, then that's going to be another case of wind shear. And what that does to the atmosphere is it actually forces it to kind of overturn on itself. You can see an example, kind of conceptual model here of what that might look like, kind of like these rotors that develop in the atmosphere as the faster winds aloft cause the top of this to spin that way, and the lower winds, the less fast winds near the surface, allow this to spin back on itself. So you got this spinning motion in the atmosphere, and we'll show it in a bit, but this is important because if the updraft of a thunderstorm can tilt that shear, instead of rotating horizontally, it can start rotating vertically, and then you get spinning storms, and you can probably guess what kind of weather hazards might be increasingly likely if a storm is spinning. We'll get to that in a bit. A couple other reasons why wind shear is important in thunderstorms. If you have a low wind shear environment or an environment with almost no shear, the rain actually falls through its own updraft. So talked about how the storms start. There's a lifting mechanism, then there's instability, and that gets air rising straight up. But then the air can't rise, straight up forever. Something eventually has to stop it. And typically what it is that stops that is the cloud itself produces larger and larger droplets of water, and then they start coming down as rain and sometimes even hail, and all the weight of that will actually come straight through the updraft if there's no wind shear to displace it. So it'll start coming down through the updraft and slowing it down, and eventually could kill off the updraft, and the storm will collapse. Whereas if you have wind shear, what that does is it causes, especially if it's, well, in either case, if it's directional wind shear or if it's speed wind shear, it actually causes the rain to move and fall downwind of the updraft. So the updraft can remain intact without heavy precipitation falling through it. And as that updraft remains intact, it'll continue to feed the storm. Storm stays intact, and severe weather is going to be a lot more likely as that storm has the opportunity to become mature. Talk a bit about different types of thunderstorms. The first is going to be the ordinary thunderstorm. This is a case where there's typically very little shear, or maybe just a little bit of shear. Starts off with the towering cumulus. This is kind of talked about this a couple times now. You got a lifting mechanism and instability, and cloud starts to grow. As it becomes mature, you start to get precipitation falling down. And in this case, because there is very little wind shear, the precipitation falls down and actually undercuts the updraft and kills off the updraft. And what you're left with after the mature storm is going to be dissipation. And this all happens in the ordinary thunderstorm, probably all within about 30 minutes to 45 minutes. So they don't last very long. A different case is going to be the multi-cell thunderstorm. And in this case, there's going to be a little bit more wind shear. And it's kind of, it almost is, you can conceptualize it as all three of these phases at the same time next to each other. So you get the towering cumulus stage and the mature stage and the dissipation stage all kind of combined, but there is more wind shear, and what the wind shear is doing is it's actually, in this case, forcing additional storms to pop up on this upwind side. So the wind's blowing from left to right, and additional storms, additional updrafts keep forming. You can see each one of these vertically pointed, upward pointing lines is an updraft. And yeah, this is a multi-cell cluster. So upper level winds are carrying the first cell downstream towards the right, with a new cell forming upstream of the previous cell, and that's what keeps happening here. These multi-cell clusters can continue to backbuild over long periods of time, sometimes for an hour or more. And what that does is it makes for like a stationary long-lived rain event, and that can lead to flash flooding. So they can, that's one of the main hazards that we can expect with multi-cell clusters that are slow moving. And the line of multi-cell thunderstorms that, especially one that's moving, that actually does have some forward motion to it, is called a squall line. And squall lines can become very intense. Very intense ones are called derechos. We'll talk about that in a bit. But this is kind of a little schematic of the cross section of squall lines. So this is like, let's say, for example, looking from west is here on the left and east is here on the right, but north-south, this thing can go on for many, many, many miles, sometimes 100 miles or more. So imagine this going deep into the picture here. But the squall lines are very well balanced between the updraft and the downdraft. So the updraft is actually tilted and coming in like this. Downdraft is tilted so that it does not quite undercut the updraft. And that is all, again, due to the wind shear. So the wind shear allows these storms to be more long-lived and can go on and produce more damage. So here's an example of an intense squall line. This is actually the same June 3rd, 2020 case that we showed earlier, what the Storm Prediction Center's outlooks look like, and then what the watch looked like. And now here is the actual radar itself for that derecho, which is a strong squall line event. So you can see new cells are continually reforming on the leading edge of the system with a swath of rain and a little bit of hail following behind it. And that is an overlay of what the wind damage reports look like. So actually were a couple of hail reports. These little green H's are hail, but the vast majority, these blue W's, all mark locations where there were strong wind gusts in excess of 58 miles per hour. And then this last thing here is a satellite loop of that same cluster of thunderstorms, the big derecho. And it also, the satellite nowadays can actually detect where lightning is. You can see those lightning flashes on this loop. So this, one more thing I'll point out here is you can actually see kind of bubbling up here. You can see some of the strongest updrafts within that squall line. So this is what an enhanced risk day might look like for this part of the country. Another type of thunderstorm is a supercell thunderstorm, and these are pretty, kind of rare in Pennsylvania, but they do happen sometimes a few times a year. They'll be scattered or isolated supercells, and these are characterized by very strong updrafts that can attain vertical pointing wind speeds of 100 miles per hour in some cases. And they're capable of producing giant hail, usually not around here. Usually kind of the higher end limit for large hail in Pennsylvania is around maybe 2-inch diameter. But out in the Great Plains, these supercells can produce 4-inch diameter hail, 5-inch diameter hail. They can get very, very strong. And supercells are also responsible for producing the vast majority of violent tornadoes. You can get weaker tornadoes with squall lines and occasionally stronger ones, but the vast majority of violent EF4s and EF5s do come from supercells. Not only the updrafts get very strong, but the downdrafts can also produce strong outflow winds in excess of 100 miles per hour. And yeah, there's an increased risk of tornadic supercells, especially when the winds turn clockwise with height, when there's directional wind shear and the wind turns clockwise. Supercells can be in the form of either low precipitation or high precipitation supercells. The low ones, low precipitation supercells, they almost never happen in Pennsylvania, but these are like kind of a classic picture of what somebody might see if they're storm chasing out in the Great Plains, especially like the dry parts of New Mexico and Arizona, Colorado, Texas. A lot of storms that form out there may end up looking like this. They're very photogenic. You can usually easily see where the funnel cloud is. Not one here yet in this picture, but may develop here. And then they're very photogenic. But the supercells that we get around here, when we do get them, are going to be the high precipitation supercells, which often, when they do produce a tornado, it's going to be a rain-wrapped tornado. Almost no chance of getting a good photo of it, and they are especially dangerous for people because you can't see the tornado coming, and if you don't get a warning, people sometimes won't know, and they can be in harm's way. Thunderstorm hazards. I'll talk a little bit more about the different types. I'm going to start off with straight line winds, and then Craig's actually going to talk in a bit about tornadoes. But straight line winds, they are the most common type of wind damage here in Pennsylvania, so a lot more common than tornadoes. They're often the result of a squall line. So here's an example here on the right of a squall line on radar, and also the yellow box here is a severe thunderstorm warning for that squall line. That squall line is moving towards the southeast, so you can see the warning out ahead of it. The strong winds are actually a combination of the forward movement of that storm, plus the transport of high winds from aloft down to the surface, and also a little bit of enhancement of cold air descending from above, and kind of splattering, moving forward, propagating out from that. So it's a combination of quite a few things that add together to produce strong straight line winds. And strong straight line winds can occur with the onset of precipitation, but also out ahead of it sometimes. Could be quite a bit out ahead before the precipitation starts. Sometimes that's referred to as a gust front, where the gust front will come out, and here's a picture of what it might look like, where the gust front produces a cloud like this. It's actually called a shelf cloud, and that's well out ahead of where the precipitation is. Precipitation, you can kind of see it here. It's a little bit more opaque and smooth looking, quite a bit farther back. So this is a schematic of the different contributions to the severe straight line winds. So like I said, you're going to get mixing of strong winds down from above. So if there's 35-mile-per-hour winds at 5,000 feet, that can be dragged down by the downdraft and the precipitation. Then the downdraft itself, when it hits the ground, it kind of splatters out, and that gets added into the stronger winds from aloft. And if you add them together, you might end up with little patches, especially where there's like stronger embedded downdrafts in that line of storms. That's where there's going to be these more localized areas of surface wind gusts that exceed the severe threshold. So winds produce damage generally in a single direction, oriented parallel to the direction of the storms, storm motion. It can occasionally be very destructive and cover a large area. Again, usually much more of a aerial footprint than a tornado. A tornado is more of a narrow swath of intense damage. But around here, winds even in excess of 100 miles per hour, they're rare, but they're possible and can happen in not just tornadoes, but straight line winds as well. Here's an example from the May 15th, 2018 outbreak of severe weather. And you can see the blue dots on this map here are all severe thunderstorm wind reports, quite a large swath of wind reports. And you can see very large trees that came down. These pictures are actually from the Danville area that we actually took on a storm survey, because there were some questions of whether or not there was a tornado embedded within this line of straight line wind damage, but it all turned out to be just pure straight line winds. Another couple of pictures here. You can see this gentleman here. I think he was probably 6'2", 6'3", a very tall guy, and you can see how big this root ball is next to him. That root ball was probably 15 to 20 foot in diameter and just laying on its side. So you just look up at it, and it was just amazing. A very old tree, a very strong looking tree too, that was just ripped right out of the ground by these strong winds that came from a straight line wind event, just a squall line here. And this is a radar loop here of the squall line event on the right. You can actually see the squall line actually slowed down and became nearly stationary over the lower Susquehanna Valley of Pennsylvania, and then even worse of an event down in the Maryland area. I think this was one of Ellicott City's big floods down in Maryland. Pretty sure that was on that date, but if not, it was an event that looked a lot like it, where there was a squall line that stalled out in that area and produced quite a bit of rain. Straight line winds, one of the ways that we can discriminate between straight line wind damage and tornado wind damage is if we look at it from aloft, whether it's a helicopter footage or a drone that went up and took some pictures. Straight line winds produce unidirectional wind damage patterns, meaning that the trees generally fell in all the same direction, maybe a little bit of fanning out or divergent footprint too, which is indicative of straight line winds. Tornadic damage will look quite a bit different. We'll show you that in a bit. Downburst winds, they are, let's see here, they're different. So it says here, similar to straight line winds, but a little bit different. Downburst damage driven by an outrush of air from a loft brought down by a thunderstorm, not due to the movement of the storm itself. Damage is often more concentrated than straight line winds. So downburst winds don't have to occur in a squall line or like a linear feature of convection and thunderstorms. They can also occur in a discrete cell, a cell that's all by itself. And this is kind of an example of what a downburst might look like falling out of a storm. And it's actually very rare to see something like this. This was just somebody happened to be there at the right moment, and the storm was just dry enough that you can kind of see through it, but yet at the same time wet enough to produce this big ball of precipitation that fell through it. So normally there's too much rain in front of this little downburst to see it, but really lucky set of circumstances that somebody was able to take this photo, and you can actually see this ball of enhanced precip come down. So first picture in time is on the left, a few minutes or maybe just 1 minute later, looked like this on the right. And then bottom left, you can see it hitting the ground, and then bottom right, you can actually see what's called a precipitation foot, how it's coming out like this. That's because the downdraft, which actually came down right about here, the downdraft hits the ground, and then the wind actually kicks back left here and kind of spirals up like this. So I'll trace out the flow of air with my mouse here. It comes straight down, starts moving out to the left, and then there's like a little rotor here where the air is spinning. So these downbursts actually used to be quite a hazard for aviation, still are a hazard for aviation, but pilots are trained to detect this. Commercial pilots now have radar to see these microbursts and these rotors and make sure that they don't ever fly through these, because there's just extreme turbulence, up and down motion with this rotor here on the leading edge of that little gust front. So this is a classic photo or series of photos showing how a microburst, which is a form of downburst, can develop. And again, a downburst, it's a straight line wind event, but has some divergent flow to it as that downburst hits the ground and spreads out and produces some divergent flow. So a downburst is a generic term for a specific type of wind damage where there's wind descending from above and then impacts the ground and spreading out from the surface at the surface. Microburst is specifically a downburst that covers an area of 2.5 miles or less, and then a macroburst, if you ever hear of that, is a downburst that has wind damage covering an area of more than 2.5 miles. So little technical details here, but different types of downbursts. So if you call it a microburst or a downburst, they're both correct, but a microburst is a little bit more specific. And last thing I'll show here before I toss this back to Craig is going to be a video of actually a microburst in New Oxford, Adams County last June. So this is June 4th, so it was the day after that big squall event. It was a very active weather pattern. So you can see a little bit of hail on the grass. So there's not only just wind in this event, but also some hail. Looks like it's about nickel size to quarter size hail. You can see it's getting quite windy now, heavy rain, and you can just imagine big ball of precipitation falling out of the thunderstorm here, quite like that series of photos. There it goes there. And yeah, as that precipitation smashes down to the ground, that accelerates the winds in a horizontal direction. Because the momentum hitting the ground, it can't just go straight through the ground, it spreads out, and that's what unfortunately took down that barn there. So yeah, this was right here in Adams County, Pennsylvania, Central PA. These things do happen, and that's why we want to be weather aware We certainly want to know about these in real time so we can continue to issue warnings and let people know to get inside and be in a sturdy shelter. And even in these cases, you actually do want to be in an interior room, just like you would want to be for a tornado. So before I turn it back to Craig, I'm going to just check here to see if there were any more questions that came in. And let's see here.
Yeah, I was trying to answer questions as they came in. I think there were a handful.
Good. Yep. I'm going to read one of them out here. It says, the person answering cannot find tone. Yeah, it looks like you answered a bunch there. Okay, yeah, great. So I don't really see any outstanding questions. Very good. So, Craig, did you want to take a break now? Or
Yeah, this is probably a good break point. Maybe we can take like a 10-minute break, get up and stretch a little bit, get a drink, use the bathroom. Let's see, I'm showing a time of 8:18. So maybe we'll give ourselves 7 minutes and come back at 8:25 and see through the rest of the presentation.
Yep, that sounds great. And if anybody does think of any more questions, feel free to type them up in the chat box, and we might take a couple before we resume. All right.
Okay, so we'll see you at 8:25 then.
All right, well, I've got 8:25 p.m. on my watch, so looks like I don't think any new questions came in. Actually, one remark. Okay. Yep, no new questions. Few came in and we did answer them on the break. So thanks, Craig, for doing that.
Sure.
And Craig, I'll turn it back over to you, and you can walk us through some tornado stuff.
Okay. Let's see here. So yeah, Mike talked about severe thunderstorms, straight line wind damage, downbursts, microbursts. Pretty impressive video we saw right before the break of a microburst in Adams County. And that shows that microbursts can be very destructive, and a lot of times we will see those and people understandably assume it was a tornado when they see how destructive it was. But you can see that straight line microburst winds can be just as damaging as an EF0, EF1, maybe even EF2 tornado. And I'm going to talk a little bit about tornadoes here. Tornadoes are, of course, a very specialized wind event. They're not terribly common. And let's see here. It's a little bit locked up on me, it looks like. There we go. Of course, it takes unique conditions to end up generating a tornado. Mike had mentioned sort of getting that rotating storm is the beginning of it. Let's see here. As I mentioned, they're rare, so I was even surprised to see this fact. Only 1 in 10,000 thunderstorms produces a tornado, so not something that occurs very often. And usually tornadoes produce a very small and defined area of damage, usually more focused than what we would see with straight line wind damage or a downburst or even a microburst. Tornado paths and swaths of damage are usually fairly focused relative to damage from a bigger thunderstorm. And as we mentioned, and as we saw in the video right before the break, the degree of damage does not necessarily indicate whether or not it was a tornado. We can get very severe damage from downburst winds, straight line winds, microbursts. So I know even myself, if I had seen that barn that was knocked down in Adams County in the footage we just saw, I might be inclined to initially think that it must have been a tornado, but yeah, we have to remember that the straight line winds can do a lot of damage. Let's see here. And so we have a poll question. On average, how many tornadoes do you think occur in Pennsylvania each year? We've got 4 choices there. I'm gonna, let's see, I'll launch this poll here, and you'll be able to give us your answer. Here we go. I see those answers coming in. It looks like we're zeroing in on the right answer. Okay, we'll close this out. Here are the results. We actually had an even split between 0 to 10 and 10 to 20, and one of those is correct. We'll move forward, and I'll let you see the answer. Correct answer is 15, so the 10 to 20 is the right answer. And that can be very highly variable from year to year, but if you sort of average out all the years together, usually somewhere in the mid-teens is about how many tornadoes we typically see annually in Pennsylvania. Now, there can be exceptions to that. Back in April of 2019, just a couple of years ago, we had a record-breaking tornado month across the Commonwealth, and you can see we had 14 tornadoes just in the month of April in 2019. So even though a typical year sees 15. In a significant outbreak, we can see that many in one day, and we did a couple of Aprils ago. And you can see the previous record before that was 11 in one day back in 1991. So this April 2019 event was pretty significant for us. And we'll take a look at how a tornado would look on Doppler radar. On the left-hand side here, we're looking at reflectivity, which is basically just showing how hard the rain is falling. So you don't really see much of anything within this that would necessarily tell you that there's a tornado forming. But when we look at the velocities, which is over on the right, this is where we get the signature of the rotation. And you can see down here, the radar is actually sort of to the bottom left of this imagery. So what you're looking at on this velocity image is these warmer tones, so kind of the reds and the oranges. That's wind moving away from the radar. And just to the northwest of that, these greens that you see, that's wind moving towards the radar. So when you think of it that way, you kind of get the you can get the impression of rotation here, where it's going outbound with the oranges and inbound with the greens, and that is what we see. And this alone would not necessarily indicate that there was a tornado occurring, but this is showing us that there is strong rotation with this storm. And so a tornado would be something that we would be concerned about. But as I said, we will sometimes see signatures like this and it doesn't produce a tornado. So just because we see strong rotation on radar doesn't necessarily mean we're going to get a tornado, but it's giving us a heads up that there is strong rotation and a tornado is a possibility. Some terms associated with tornadoes. This is what you would call a wall cloud, and it's usually a lowered cloud base that is rotating. And you'll see that word a lot here in the coming slides. Rotation is a key part of this, and a wall cloud is rotating. Doesn't look like there's any sign really of a tornado or a funnel with this yet, but it is a rotating wall cloud, that low-hanging cloud there in the middle of the storm. They look impressive, but you're not going to see any damage just because you have a wall cloud passing overhead. But a wall cloud can be indicative of possibly something more that could be happening imminently. Now, the next step you would probably see from a wall cloud is a funnel cloud. And a funnel cloud is just a quickly spinning funnel that's descending from a thunderstorm cloud, but not yet touching the ground. And again, as with the wall cloud, rotation is the key. So if you see something like this, but it's not rotating, it may just be what we call scud. And some of this back here, some of these darker clouds away from the funnel, is probably just scud clouds. And it does have more of a look of a funnel, but if you see it rotating, that's really the biggest tip-off that you're seeing a funnel cloud. And again, even though seeing a funnel cloud is impressive, if you're not seeing anything translating to the ground, then it's probably not doing damage yet, and it's not really a tornado. It's just a funnel that has not quite made it to the ground. Now here's the real deal. This is a tornado, a funnel that has reached the ground. You can see the debris being kicked up here at the ground. And again, rotation is the key, and we're gonna see kind of an interesting example and some footage in one of the upcoming slides of why rotation is the key. Of course, this looks like a pretty classic tornado. If you saw this, there probably wouldn't be very much doubt. We usually don't get this good of a view of a tornado in Pennsylvania. As Mike said, a lot of our storms and a lot of our tornadoes tend to be rain wrapped. This more than likely is a picture from out in the Great Plains where the storms are a little drier and you have better visibility below the storm. And I've got a couple of videos here. We'll start with the one on the left. And this is interesting. You'll see the winds start to pick up, and you see the winds moving from left to right. And you'll see that change as a tornado approaches. So see how the winds all of a sudden shift direction? Now they're getting pulled back towards the tornado. And you can see what happens here as the tornado nears. There goes the roof. And unfortunately, I don't think it ever clears up enough that we see what happened to the house, but it wasn't looking very good. The video on the right is going to start, and this is the view from inside. I don't know if that's a bank or just an office building as a tornado approaches. You'll see out the window here that you'll start to see the bushes getting thrashed about. And then the window gets blown out and all heck breaks loose in the office there. Somehow it looks like the camera survived, even though it got knocked around quite a bit. You can see what looks like a door here, but a couple of impressive videos of tornado strikes. Let's see if we can advance this. Here we go. This is an aerial shot of some tornado damage. It's a little bit difficult to see from this distance, but this is probably a shot from an aircraft. But typically with tornado damage, we will see a crisscross pattern in the fallen trees. So with straight line winds, everything tends to fall in the same direction. With a downburst or a microburst, we tend to get that fanning out. With tornadoes, it tends to be more chaotic, and a lot of times you'll see crisscrossing where there's trees sort of laid across one another. It's a much more chaotic pattern of damage, or fingerprint as we're calling it here. And here's a couple more aerial shots of tornado damage. It's hard to see from this distance, but there is a bit of a convergent pattern here, things coming in towards the tornado, and you can see that path across the field here, the crop damage. And in the bottom left, this is a picture from Wisconsin. You can actually see the cyclonic rotation here in the way the crops were knocked down, and that is a good sign that there was a tornado that came across this farm field. Here's another aerial photograph of some tornado damage. This is from October 2nd, 2018. This is a picture, I'm not sure, this may be Tioga County in north central Pennsylvania. I'm not positive, but this was some tornado damage. Again, it's a little bit difficult to see. If you were down on the ground, you'd probably get a better idea of the crisscross pattern of the way that some of the trees fell. Here's the video I was talking about, and this is going to be a poll question. But we'll watch this video, and what do you think that you would call into the National Weather Service if you were observing this, say from a hillside at a distance? This was moving across the valley in front of you. Let's see. I'll get ready to launch the poll here. So you're a little ways away. You can see it's breezy, and you're wondering what this is right here in the middle. So I'm going to launch the poll question. What would you call what we just saw on that video? And this is a tricky one, and I'm not sure that I would have gotten it if I was witnessing it myself in real time. Okay, it looks like the responses have stopped coming in, so we'll share the results. Looks like the majority would call it a funnel cloud followed by a tornado, and actually, you'll see the key to what this was is something that we mentioned on some earlier slides. The key to this is it rotating? And you can see they zoomed in on it, and it's really not rotating. There's no rotation seen here. It sure looks from a distance like it's a tornado or a funnel, but because it's not rotating, the correct answer is actually, let's see here. The correct answer is actually, you could call it in, but the correct answer is it's not really anything. It's not a tornado. It's not a funnel cloud. Not necessarily indicative of damaging winds. Mike and I were talking earlier about what we think this might be. You can't really get a good view from where you are, but there could be a lake or a pond or something down here. We were thinking where there's a source of water, and this is an updraft passing over that, and so it's pulling some of that moisture up, and the moisture is quickly condensing as it's moving up into that updraft. But with no rotation, it's definitely not a tornado or a funnel cloud. So that's a tricky example because it does look very ominous, but yeah, with no rotation, it's not a tornado or a funnel. And we've got a few more examples of tornado, funnel. What do you think it is? The first one on the left here is from October 2nd, 2018. This is Cumberland County, west of Harrisburg. And the one on the right is Clearfield County from that same day. And this was a pretty big severe weather outbreak that we had in October a few years ago. This actually is a funnel, and you're at quite a distance, but I think right in here there is actually a funnel hanging out of this this wall cloud. The one on the right, however, we determined was not a funnel cloud, and we're not sure. I don't know if this was some sort of outflow pushing from left to right that was causing a bit of a wedge shape in the clouds. But we did get this picture, and where there was some debate in the office for a little while as to what it was, but we couldn't identify any rotation. I don't believe we saw any on, maybe we were looking at radar from that, and there wasn't really much rotation. But from what we could tell, this was not tornadic on the right here. A couple more examples. These are from the Harrisburg area a couple of Mays ago. This was actually a picture that was on the Weather Channel, and I believe there was a significant tornado threat that day. And so we have a couple of pictures from the Harrisburg area from this day. The picture on the right was confirmed that this actually was a tornado, or rather a funnel cloud. This was rotating. The one on the left, however, I believe was not a funnel. This was just some scud clouds, and it looks like there's some lower hanging scud, but from what I understand, it wasn't rotating. So this was in fact not a tornado or a funnel cloud, but the one on the right was. And again, that's because they were able to identify the rotation happening with that. Now we'll talk a little bit about hydrology and flooding. And we've got our sad cow. This was down in Lancaster County. I don't remember if it was a year or two ago. We had some flash flooding down there. And this cow does not look too thrilled to be standing in the water there in the field in Lancaster County. We'll start with a little bit about river flooding. River flooding is handled by the river forecast centers. So for the Susquehanna Valley, that would be the Mid-Atlantic River Forecast Center, which is co-located in our office. These are for specified gauged locations in some of our rivers and bigger streams. These are typically locations where it takes a little while for the water to respond. So these tend to be our bigger streams and rivers where the water falls and the first response comes from the smaller streams and creeks. It takes a while to get to the bigger creeks and rivers, and those are typically where we have our gauges. And the river forecast centers will issue forecasts for river stages at those forecast points. Many of our smaller streams and creeks are not gauged, and typically if we have flooding on those smaller streams and creeks, we will issue flood or flash flood products. These river points where we actually have gauges, we will issue point river flood products. And we've got some of the things that drive river flooding. Of course, the routing of upstream water that's coming out of the tributaries, the smaller streams and creeks. Reservoir and dam releases. We've got a lot of reservoirs and dams across central Pennsylvania, and those releases can have an impact on river stages. And also the time of year impacts how much water is getting into the rivers. Once we have green up, the trees and the vegetation is pulling a lot of water out of the soil, and so that can actually help decrease a little bit the impact of the rain as some of that water is going towards the vegetation. In the wintertime, we don't have that as much, so pretty much all of the water that comes down is going right into the rivers and streams in the wintertime. Now this is a forecast, or this is a hydrograph. This is the Youghiogheny River at confluence, and that eventually flows into the Monongahela River, which heads towards Pittsburgh. So this is a part of the Ohio River Forecast Center. This is part of the Ohio River Basin. But this is in Somerset County, so it's one of our areas of interest. And this shows on the left, the blue is the river stage as it progresses through time. And then once you get to the right of this vertical line, the purple line is the forecast stage. And you can see if you're down in the white, you're in good shape. Everything's in its banks. Once you get to action stage, you're starting to get concerned that maybe some minor impacts along the banks. And once you get up into the orange, you're into minor flooding. The red is moderate, and the purple is major flooding. So you can see this forecast had it getting just shy of minor flooding. And Confluence is a site that is somewhat controlled by a dam upstream from there. So it's possible that the folks at the dam were able to hold enough water back that it wasn't going to end up causing flooding at that point. Not all of our river points are that lucky that there's control above them. And sometimes if enough water comes down, even the dam won't be able to hold enough back. They'll have to release enough that it may actually get up into flood stage. Here's a link if you're interested in seeing what kind of river points you have, forecast points in your area, water.weather.gov. Again, you don't have to write that down or anything. We'll be sending this presentation to you in an email tomorrow, so you can check out that site. Some of the flood alerts products that we have from the National Weather Service. We have flood watches and flash flood watches. We also have flood advisories and then flood and flash flood warnings. And as you progress from left to right here, you're getting into more, I guess, where it's more of an imminent threat. A flood watch is just a heads up that flooding is possible, so be prepared and stay tuned to the latest weather information. An advisory means that flooding is imminent, but it's probably not going to be life-threatening flooding. This may be more nuisance flooding, ponding of water on roadways, in urban areas, significant rises on rivers and streams. Maybe some places will get just out of their banks, but nothing too serious. Once you get to flood and flash flood warning, that's when it's a more significant threat and it may be life-threatening. And that's when it's a good idea that if you're near one of these streams to move to higher ground. Something we always like to reiterate is never drive through flooded roadways. We have the famous phrase, turn around, don't drown. If there's water over a roadway, you don't know what condition that roadway is in underneath the water. You can't see through it, and it's possible the structure of the roadway has been eroded away. And if you drive into that, you're just going to fall right into whatever crater has been left behind by that moving water. And that's how, I believe that's how most of our fatalities in flooding occur in central Pennsylvania, is people driving into flooded roadways and then their cars being swept downstream. So yeah, turn around, don't drown. Now this is flash flooding. We talked a little bit about river flooding earlier with the official forecast points. Flooding and flash flooding, we typically issue these for streams and creeks that are ungauged, or for areas that are not near a gauge, say on one of our official river forecast points. A lot of times what causes the flash flooding is either a slow moving, heavy rain producing thunderstorm. A couple examples that I think of right off the top of my head from this are the two bigger floods that happened in Johnstown. Of course, the famous 1889 flood, and then much more recently in 1977. Both of those events were thunderstorms that just parked themselves over the Laurel Highlands and produced a lot of rain. Another source of flooding rainfall can be what we call training storms, where storms repeatedly train over the same area. So you just get storm after storm. The one event that Mike showed earlier, where the flooding happened eventually down in Ellicott City, as that line kind of became more east-west, those storms started training right over top of where the previous storms had occurred. And that ended up causing flooding in the Ellicott City area down in Maryland. And of course, dam breaks are always a threat. There's a lot of dams in central Pennsylvania. And both of the Johnstown floods that I mentioned, which were caused by thunderstorms that just sat over that area, also involved dam breaks. Of course, there's the famous South Fork Dam with the 1889 flood. But even in 1977, I think some of the most severe flooding damage was due to a dam break that occurred upstream of Johnstown. Typically, the smaller streams and creeks respond much faster than the rivers do. So a lot of times it's more of an imminent threat. If you're getting heavy rain and you're near a smaller stream or creek, there could be a quick response where that water comes up very quickly. And then, as I mentioned earlier, it takes a little while longer for the bigger streams and creeks to respond as that water comes out of the smaller streams and into those bigger waterways. Flash flooding, of course, is a significant threat to life and property. We can get flooding from longer duration, moderate rainfall, but usually that develops more slowly and is less likely to be a flash flooding type of a situation. It can cause rivers and streams to eventually get out of their banks, but really it's these convective thunderstorms with the very localized heavy rainfall. Those are typically the events that produce significant flash flooding. Aerial flooding, again, this is usually sort of like the longer duration, moderate rainfall event I had mentioned on the last slide. You may end up with an aerial flooding issue, but some of the same I guess setups apply in this case, where it keeps raining for a prolonged period of time, or you get storms training over the same area. You can end up with widespread aerial flooding. Let's see. That says more of a threat to property or life. I don't know that that's more of a threat than flash flooding, but it can be an equal threat to flash flooding. Let's see here. I think this is where I hand it back to Mike. Mike's going to get into some spotter reporting guidelines, and he will see us through to the end of the session here.
All right, great. So yes, I'll advance to the next slide. Okay, so I'll start off with a poll question. True or false? It is safe to chase storms, especially at night. What do you all think? I'm gonna open the question, launch it. Votes coming in quick. All right, happy to see a unanimous answer here. So the answer, of course, I won't even share it. It was unanimous. The answer was no. I'm glad you all know that it is false. False. It's not safe to chase storms any time of day, really. There's always a lightning threat. So keep that in mind. And then especially at night, nighttime is definitely, there's a lot of risks out there. You can quickly come upon a downed tree or something like that, or a flooded roadway. Quickly come upon them that because they're difficult to see in the dark. So really, we're training everyone to be, of course, storm spotters and observers, but not necessarily here chasers, because there's quite a bit of risk involved with that. So what a spotter is, someone who observes the weather and communicates the weather with us so that we can communicate with the partners and continue to include more higher confidence information in our warnings. And spotters, we definitely want you all to stay safe. Critical role in spotters, yeah, they serve a critical role in helping the National Weather Service and local officials. But they're not necessarily a weather expert. Some of you are, I will say that. Some of you are weather experts, and we appreciate you being on the line. Some of you, a couple here and there, especially some SKYWARN spotters out in the Great Plains, some of them are storm chasers, so we're not going to deny that either. But of course, none of us are above the law. None of us are immune to the laws of physics. So yeah, this slide's here just to say we want you all to be safe. So what to report? Few things that we want to make sure are included with every report. One is time. When did the storm damage occur? We want to know what time it occurred, not necessarily the time that it is currently or the time of the call. So if you're going to call us in a few minutes, please just do the best you can to note the time that you saw the hailstone fall or the tree go down or whatever it was. Note the time and then let us know when you do give us a call. Location-wise, you want to know where. If you're unsure exactly where you are, give us a nearby intersection or landmark. Lat-Lon is good if you happen to have GPS with you. But if not, if you give us a good landmark, we'll probably be able to figure it out using Google Maps or whatever else. We want to know the condition of what you are reporting, and we want to know the source. So tell us that you are a trained SKYWARN spotter, and that'll make us trust you even more because you've gone through this training, and we appreciate that. So here's an example of a strong call coming in from a spotter. Start off, hi, this is John. I'm one of your spotters, and I'm calling to report hail. I'm located in Lancaster City, and we've got at least quarter-size hail falling right now, so we know the time. And maybe it's larger, maybe even a little bit larger than quarter-size hail. So you're even conveying some uncertainty there, which is good to know. If you're not exactly sure, we want to know kind of what the range of possibilities might be. Late reports are okay, but of course not ideal in a rapidly evolving situation with a lot of threat like a tornado. We really do appreciate pictures and videos, absolutely love them on social media, and if you email them to us, they go a long way. Picture tells 1,000 words, and they can, especially if you're reporting something that is rare or very isolated, can really help add confidence to the report. And please remember to tell us where you are. That's extremely important. This is an example of a bad call here. Yo, it's getting dark here. Looks like it might be a tornado. Not specific enough. You're not telling us where you are. And looks like it might be a tornado. We have no idea if you're seeing a tornado, if it's actually rotating, or if it's one of them tornado lookalikes like Craig was showing earlier. So here is a little guide here for different types of weather hazards and damage that might be produced, or what you might see in order to trigger you to call the weather service. For wind damage, we want to know about uprooted or downed trees, any large branches that are down, wires down, damaged infrastructure or property. Of course, again, photos go a long way. For hail, we actually want to know hail about, we want to know about hail of any size. So it doesn't necessarily have to be quarter size, severe limit hail for us, for you to call us. Because if a storm that we don't think is producing hail is producing nickel size hail, well, we know if it gets any stronger, we're going to throw a warning on that because it might get larger and become severe. If you do measure the hail, we of course appreciate if you do measure the hail. Please measure it with a ruler or a common object. And again, for hailstones, we want to measure from the largest or longest axis. So just be mindful of that. If possible, you can measure the weight of the hail, but that's pretty rare. I think that's only for the most giant of hailstones. Typically, we just want to know the size. And you can give us the size in inches, but also in terms of like coins or other common objects. Coins are specifically very useful because we all know the size of those coins, whereas if you tell us something like marble-sized hail, that doesn't really tell us much because people have different sized marbles. If you tell us, grape-sized hail, that doesn't tell us much either because grapes come in different sizes too. So coins and inches are really some of the most helpful for us, and peas too. Peas are pretty standard. I've never seen a giant pea. Maybe they're out there. Tornadoes and funnel clouds. We want to know if you see any visible rotation in a wall cloud, or if you see a funnel or a tornado. Again, pictures are great. Videos are great too. Videos are especially useful for showing rotation in a funnel or a tornado. But of course, that being said, we don't want you to be out there if a tornado is coming down on your house. We want you to take shelter. Don't put yourself in jeopardy for any of this, please. And then finally, flooding. We want to know about any significant flooding. If you see water in areas where you've never seen it before, that's going to be significant. We want to know about that. Some of our biggest events were kind of characterized by people calling us and saying, hey, we've never seen water in these areas. And if that's happening, the flood prone areas are just really getting hit pretty hard at that point. We want to know about water over roads that are closed. We want to know if anybody's stranded in a vehicle in the flood waters, or if there's ongoing water rescues. And again, photos are great. And again, time, location, and what you're reporting and who are you all go a long way. Snow, we want to know snowfall reports during the storm if possible. So the nearest 1/10 of an inch again is how we officially report snow. And then we want to know the storm total if you can report that towards the end of an event. Another important thing is if the snowstorm goes over to mixed precipitation or rain, we want to know the snowfall amount before that mix takes place, because the mix can cause that snow to melt or compact it down with the weight of the rain or the sleet or whatever else is falling on it. And snowfall rates are also really important, because they're extremely important for the transportation folks and people whose job it is to keep the highways clean. They are very sensitive to the snowfall rates. Once it gets above 1 inch, it becomes a little difficult, and above 2 inches per hour, it becomes really difficult to keep up with the snowfall rates. So whenever it's approaching that, we want to know. And we have some pretty good skill detecting, predicting that and detecting it in real time using the radar and the models and some other tools. But of course, the spotters, they just provide us with so much more increased confidence with the ground truth that you provide. It's just huge. So please, if you know something, let us know, and we will all benefit. Sleet, we want to know if it's occurring or accumulating, and freezing rain. Be very careful when you go out and measure this. Of course, it's very slippery, but Craig showed you how to measure that earlier. How to report, here's some numbers that, again, this will be included in a reference guide that you're all going to get in the email tomorrow, but those are our unlisted and listed numbers there that you can call in on. I really want to stress and emphasize that we want to know about severe weather in real time as much as possible, because that will let us know to keep issuing the warning, and that'll be added into the warning source in the text and increase the confidence for people receiving that warning. Facebook is a great way to share photos and information with us. But we're not going to see it quite as quickly as if you call us on the phone. We'll have somebody monitoring Facebook, but it's not an operational, an operational product or tool that we're using in the office. It's something that if you send us a picture, we might see it in 5, 10, 15 minutes. And if it's a tornado, 15 minutes is a long time, and a tornado could be dissolved. Dissipated by that point. Same thing with Twitter, and same thing also with email. Those are all great ways to share information and photos and videos, but we're not going to see it as quickly. So what's next? Like we said a few times, an email is going to be sent to you tomorrow. What to expect? We're going to ask you if you're a spotter already. We're going to get your contact information. I think we're going to ask a little bit about your thoughts on the course. And if you're not a spotter yet, you will receive a spotter confirmation letter, and please be patient as we process through everybody. There are quite a bit, but I saw a couple questions come up in the chat, and just because some of these were asked a few times, I just want to answer them for everybody. I saw a couple questions about the spotter IDs, maybe some concern that doing away with the spotter IDs is kind of like delegitimizing, I guess, the essence of the spotter, but that's simply not the case. I think the whole reason behind the spotter ID in the past was that if you called and you gave your spotter ID number, it would be a quick way for people to look up that person and see what their location is. But the thing is, so many people are moving around these days that if we just rely on that spotter ID for location, it's just it's not reliable. So from this point forward, we're just going to always ask a spotter, what's your location, just to make sure that that's accurate. And we'll probably ask your name, and we will keep a big database of the spotter names, first and last names. So by you telling us your name, we're going to know you're a legitimate registered spotter. So don't worry about that. And yeah, that was the main question that I saw come up a couple times. There's a question: are there advanced spotter training webinars? And the answer to that is yes. There's probably going to be another one. They're typically like once or twice a year from this office, so there's probably going to be another one some point this summer. But I don't have the date offhand, and we could throw that in the email that we send out tomorrow. Any other questions here?
There's a recorded one.
There is also a recorded one that you can access on our YouTube channel, so that is there too. And let me just see. Yep, the note about the spotter IDs, I already just explained this. Of course, if you have one, keep it, but we're just not going to generate new ones. And yeah, I actually see a few raised hands, but I don't know if those have been raised for a long time. I'm going to unraise everybody's hand, and if you do have a question, please re-raise your hand, and we'll take it from there.
Yeah, I wasn't sure how to handle those raised hands. I tried to answer the questions as they came in.
Yeah, I think most questions are coming in via this chat, but if you do want to ask a question to us verbally, you can raise your hand now, and we'll see it, and at that point, we will unmute you or give you the ability to unmute yourself. But otherwise, not seeing many other questions, so just want to thank everybody again for being with us tonight, spending the past 2 hours and 8 minutes with us. Appreciate your time, and we really appreciate all the things that the spotters do for us, and it's a relationship that we really take pride in, and we want to continue to build, continue to provide good content for you, whether it's advanced spotter training, if some of you are interested in that. And we also have a SKYWARN newsletter that we're putting together again. That's something that was it was ongoing for a number of years until one of our senior forecasters retired, and then it kind of lapsed for about a year. But we brought that back, and we brought it back quite strong. One of our new hires put a lot of effort into kind of editing that, and now it's a spiffy little newsletter that we're going to be sending out to our spotters with some information about what our office is up to and some cool stuff that's coming out in the science too. So hope you enjoy those, and thanks again. Hope you enjoyed this webinar, and yeah, be on the lookout for an email tomorrow. Not seeing any raised hands, and no additional questions. Great. Well, have a good night, everybody. I think we will be signing off.
Okay. Yeah, thank you, everybody. We appreciate you attending.
Thanks again.